Assalamualaikum warahmatullahi wabarakatuh. Okay, today I'm going to present the numerical method project assignment, section 3, group 8. Okay, let's go. So this is our group members. Okay, first Ahmad Amirul Ashraf bin Osman, and the second one is Khairuddin bin A Husaini, and the third one Muhammad Shazmin Shah bin Ishaq, and the last one is me, Muhammad Ihsan bin Isham. Okay, so the introduction of this project. An RC circuit consists of two elements, resistors and capacitors. An RC circuit is a second order electrical circuit. It is most commonly used to construct oscillators and tuners for radio or audio receivers. A circuit equation is drawn to undertake the analytical part of a transient analysis. In this figure, the electrical elements, resistor and capacitor are connected in series with the DC source. Numerical methods could offer great relief to the solution of complex RC circuits, and ordinary electrical circuitry could contain thousands of components. Therefore, any analytical solution in such RC circuit is virtually impossible. We use possible iterative method to solve the circuit equation under the terms of transient analysis in an RC circuit and compare different methods. So the methodology, the figure shown the RC circuit. Current through the resistor and the capacitor has the voltage drop Q over C. Q is the charge on capacitor at time t. When the switch is closed at time t equal to 0, by applying Kirchhoff's law, we get the equation E equal to IR plus Q over C. A few math steps will give us the equation in the form of Euler's method as below. dq over dt equal to E over R minus Q over RC. We are going to use equation 2 to write the code and plot the approximation graph in MATLAB. So the given parameters, E equal to 200 volt, R equal to 1500 ohm, C equal to 0.025 farad. So the initial condition is Q equal to 0 at T equal to 0. So the question is find Q at T equal to 1. Okay, then I pass the presentation to my group members.
Assalamualaikum warahmatullahi wabarakatuh. My name is Khairuddin bin Husaini. So I will continue the presentation with the next part, which is method. In this project, we use two methods. Firstly, Euler's method. Euler's method is a technique to solve first order initial value problem and numerically. The standard form of equation for Euler's method is given as y prime equal to f xy, where y x naught equal to y naught is the initial value. We need to find the value of y at point n. The blue graph show the z, and the red or tangent line is the Euler's method. We use the tangent line as an approximation at the only known point to us, x0, y0. Then move a short distance ahead on this line, which is close to our true solution, x1, y1. We now use the x1, y1 to plot the point x2, y2 in the similar fashion. Repeat the step until you have reached the final point xn, yn. Okay, next slide. The second method that we use is Rush-Kutafor method. The most commonly used Rush-Kutafor method to find the solution of the differential equation is RK4 method. Is, for example, the fourth order Rush-Kutafor method. The Rush-Kutafor method provide the approximate value of y for a given point x. The formula for the fourth order Rush-Kutafor method is given by y1 equal to y0 plus 1 over 6 multiplied by k1 plus 2k2, 2k3 plus 2 plus k4. Okay, next, k1 equal to hf x0 y0, k2 equal to hf x0 1 over 2 h y0 plus 1k2 plus multiplied by k1, k3 equal to hf x0 plus 1 over 2 h y0 plus y over 2 k2. And next, for the last, k4 equal to hf x0 h y0 plus k3. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name Ahmad Amirul Ashraf bin Osman. Okay, in this video, I will explain about the result and the analysis. Okay, in our project, we use Euler method and Runge-Kutta RK4 method to compare the which one of the method that near to the exact value. So this is the Euler method. This is the equation of the method. This is the equation of the circuit. So we rearrange the equation in the Euler method, and then we put the value in a calculator, and then we get the Euler method value from 0 to 1, the step size 0 to 1, and then we get the answer of Euler and the answer of exact. This is the equation of the exact. Okay, and then we also put the value in a fourth order Runge-Kutta method RK4. We find the K1, K2, K3, and K4, and then we get the value of the RK4, put it in the table from 0 and 1. This is the value of the RK4, and this is the exact value of Q. Then we try to simulate the Euler method and RK4 to make sure the answer is right. And then we go to the MATLAB. This is the coding of the MATLAB for Euler method and RK4, and this is the exact value. So we have done the coding, and then we run. And then we get the graph for exact value and the Euler method. We can see the graph is near to each other. Okay, so if we want to see the value of the Euler method and the Runge-Kutta 4 method, we can see wait, is the value of the value of Euler method that we get from the coding MATLAB. So the value is same with our calculation for Euler method is 0.0133, and this is also 0.0133. For the RK4, we can see the value of RK4. So the value of RK4 also same with the calculation 0.0132 and 0.0132. So for our observation, we can conclude that the Runge-Kutta method is the most near to the exact value, so we can use the RK4 to solve the first order linear equation. Okay, that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. I will continue our presentation. So first, I will present about discussion. Okay, as the result of the simulation and calculation, we compare the numerical solution from manual calculation and simulation from the MATLAB. Okay, from the result, we get the same answer for manual calculation and simulation. We had to approximate the charge on the capacitor, and then we use Euler method and fourth order Runge-Kutta method to compare the accuracy of the numerical method that which one near to the exact solution. Okay, from the hours observation, the data that we get from Rosqueta method is the efficient method compared to the Euler method in solving second order differential equation. Okay, from this project, we can conclude that the charge on the capacitor in the circuit is analyzed using analytical method, which are Euler method and fourth order Rosqueta method. Okay, with the uses of simulation software, the process of obtaining result of the charge in capacitor is done systematically and conveniently. Okay, from the simulation result, we can conclude that Rashketa method is more efficient in solving first order differential equation. Okay, hence we could safely use Rashketa method to solve it even in the problem where we do not know the exact solution. Okay, our recommendation is to make sure that we employ a technique that is appropriate for the question purpose. And it is also necessary to know how to use the procedure before using it. Because we will have some trouble obtaining the answer to the manual calculation and simulation part if we adopt the incorrect methodology. Okay, that's all from our group. Thank you.